Are floor tiles really colder than wooden floors? Why does concrete or metal feel colder to the touch than wood? Let's start by moving the first false idea out of the way. Let's assume that we are in a room with a stable temperature of 20 degrees Celsius or 68 degrees Fahrenheit. All systems tend towards a thermal equilibrium. This means that any object hotter than the ambient temperature, such as a radiator, will lose its heat to the surrounding air. And any object colder than the ambient air will steal some thermal energy from it until everything in the room reaches 20 degrees. So if we assume a well-insulated home and exclude prolonged swings in temperature or floor heating, both wood and ceramic tiles will reach the same temperature as the ambient air after a few days. There is no mechanism by which ceramic should systematically end up at temperatures lower than wood, as long as we don't involve any radioactivity or nuclear reactions. Now, both materials are at the same temperature, which is around 14 degrees centigrade lower than the average temperature of our skin. That's quite a difference. Shouldn't they both feel equally cold? In fact, it has to do with how fast the thermal energy is pulled away from our skin, or how effective is the material in transferring heat. This property is called thermal conductivity and is expressed in watts per meter per degree centigrade. In other words, it tells us for any specific material how much energy it will transfer every second over a meter of distance for each degree centigrade of temperature difference within the material. Very simply put, how fast will it propagate heat throughout itself? In the case of an oak wooden floor, for example, the thermal conductivity will be between 0.1 and 0.2 watts per meter per degree Celsius. Whereas ceramic tiles can reach thermal conductivity values as high as 1. That means that ceramic will suck the heat out of our feet 5 to 10 times faster than wood while being at the same temperature. And the difference is even more striking with metals. Stainless steel, for example, will transfer heat more than 75 times faster, and copper more than 2,000 times faster than wood. So for the same amount of time, we will lose much more heat to a ceramic or concrete floor, creating this feeling of cold. That also means that despite the slower rate of heat transfer, our body will manage to bring the surface temperature up on wooden floors faster than on tiles. Does that sound counterintuitive? Let's visualize a slab of wood with a certain thickness. When our foot touches its surface, it immediately starts pulling the heat away and warming up itself. And it does so progressively, over its depth and sideways. Each molecule farther away keeps pulling the heat away from the molecule closer to us, but it does so slowly enough that the molecules closest to our skin reach and maintain temperatures that no longer feel cold to the touch. With a ceramic surface, on the other hand, as soon as the surface molecules pull some heat away from our skin, their neighbors immediately pull it farther and farther away into the material, 5 to 10 times faster than in the previous case. So, the energy is spreading farther and faster. It needs to be shared with a greater mass of the material, resulting in a slower temperature increase at the surface. That is why wooden floor or surfaces may briefly feel cold to the touch but rapidly become comfortable to sit or lay on, whereas floor tiles or concrete feels much colder, even at normal ambient temperatures. Please let us know if you like the content and what other topics would you like us to cover in the future.